ideal chemistry. Today's session we are discussing about oxides of nitrogen. The nitrogen can consist of 5 type of oxides. We already discussed at reaction with the oxygen. So we will be discussing about each oxide one by one. So I just take this a few columns. Name of oxide, formula, oxidation state, structure, and preparation. So just take a few columns. So we will fill one by one. So first one, nitrous oxide. What is nitrous oxide? Its formula is En2O. In the nitrous oxide, the nitrogen can have a +1 oxygen state. When you see the structure of nitrous oxide, it have 2 nitrogen bonds connected by 1 double bond, and 1 nitrogen oxygen can be connected by 1 coordination covalent bond, or you can call it A2 bond. Okay. And how to prepare the nitrous oxide? The nitrous oxide can be prepared by the heating of ammonium nitrate, Na. So ammonium nitrate, NaH4, NO3 undergoes strong heating. It can be formed N2O, nitrous oxide, and 2H2O. So this is the preparation of a nitrous oxide. Once again, see nitrous oxide. The formula of nitrous oxide is N2O. Its oxygen state is +1. The oxygen state of nitrogen is +1, and the structure of nitrous oxide is look like this. And the nitrous oxide is prepared by heating of ammonium nitrate. And the nitrous oxide is colorless gas, and in huge quantity it is poisonous nature. It acting as a poisonous gas at a high concentration, but at low concentration it acting as a laughing gas. Okay, this is about the nitrous oxide. Next one is nitric oxide. So nitric oxide, the representation of nitric oxide is NO. In the NO, the oxygen state of nitrogen is +2, and the structure of NO is nitrogen triple bond oxygen. So in between of nitrogen oxygen we have the triple bonds. In that one bond is made by 3 electrons. Then it's called as a odd electric bond. What we call as odd electric bond. In the NO, between the nitrogen and oxygen we have the triple bond. In the triple bond, one of the bond is made up of 3 electrons. We call as a odd electric bond, and it is a paramagnetic in nature due to presence of a single electron. So the nitric oxide prepared by the direct combination of nitrogen and oxygen. At the same time, when copper is react with nitric acid, it can be formed the copper nitrate and nitric oxide as a byproduct. So these are the preparations of nitric oxide. And third one is dinitrogen trioxide. What is dinitrogen trioxide? The formula of dinitrogen trioxide is N2O3. In the N2O3, the oxygen state of nitrogen is +3, and when you see the structure of N2O3, the 2 nitrogen atoms are connected by a single bond, and the entire structure of N2O3 is look like this. And I will point out the lone pair electrons. The oxygen with a single bond. Actually, this bond is coordination covalent bond. So these oxygen consist of 6 electrons. These oxygen consist of 4 electrons, and it is also consist of 4 electrons. This is the structure of dinitrogen trioxide, and it is prepared by the combination of nitric oxide and nitrogen dioxide. The dinitrogen trioxide is a combination of nitric oxide and nitrogen dioxide. And dinitrogen trioxide is a blue colored solid. So it's a blue colored solid. N2O3. So N2O3 is a blue colored solid. And next one is nitrogen dioxide. Nitrogen dioxide. So it is represented with the NO2 formula. In the NO2, the oxygen state of nitrogen is +4, and when you go for the structure, it consists of one day2 bond and one double bond. So this is the structure of a nitrogen dioxide. So when I observe the structure of nitrogen dioxide, the nitrogen consists of single electron, and it is also have the paramagnetic nature. And it is prepared from nitric oxide. When nitric oxide is react with the oxygen, it can be formed a nitrogen dioxide. So when nitric oxide is react with oxygen, it can be formed a nitrogen dioxide. And another way is when lead nitrate PbNO3 taken to, when 2 moles of lead nitrate undergoes decomposition, it can be formed the 2 moles of lead oxide and 4 moles of nitrogen dioxide and O2. So these are the two preparation methods of nitrogen dioxide. And the nitrogen dioxide existing as a dimeric form. So the dimeric form of nitrogen dioxide is dinitrogen tetroxide. Dinitrogen tetroxide. So it is represented with N2O4. This is the dimeric form of nitrogen dioxide. Here the oxygen state of nitrogen is also +4, and when you go for the structure is look like so when I represent the lone pair of electrons, so this is the structure of nitrogen tetroxide, and it is prepared from the nitrogen dioxide. When 2 moles of nitrogen dioxide undergoes dimerization, it can form the dinitrogen tetroxide. Actually, the nitrogen dioxide is a reddish brown color. Reddish brown color. So the nitrogen dioxide is present in reddish brown color, but when it is changed to the dimeric form, it is colorless. Okay, this is the dinitrogen tetroxide. And last one is dinitrogen pentoxide. Dinitrogen pentoxide. It is represented by N2O5. When you go for the structure, the both nitrogens are connected by an oxygen. Remaining structures look like dinitrogen tetroxide. The only difference between dinitrogen tetroxide and dinitrogen pentoxide is oxygen. These oxygen. Okay. So again, I will reprint the lone page. So this is the structure of dinitrogen pentoxide. I just remember this. The oxygen state of dinitrogen pentoxide is +5. What is +5? And it is prepared from nitric acid. When nitric acid is treated with phosphorus pentoxide, it can be formed the dinitrogen pentoxide. Like what I said, when nitric acid is react with phosphorus pentoxide, it can be formed the dinitrogen pentoxide. 4HNO3. react with P4O10, phosphorus pentoxide, it can be formed 4HPO3 plus 2N2O5. Actually, dinitrogen pentoxide is a colorless solid, but it can be exhibit the yellow color due to decomposition of dinitrogen pentoxide to the nitrogen dioxide. So actually, dinitrogen pentoxide is a colorless solid, but it can be exhibit the yellow color due to decomposition to nitrogen dioxide. So these are the oxides of nitrogen. So thank you students. If you like my videos and my teaching, please subscribe my channel and please like my videos, and please share my videos to your friends and in your social sites. Okay.